Welcome to our channel. Today we're diving into the awe-inspiring world of astronomy with a focus on our closest celestial neighbor, the Moon. We're about to uncover some incredible facts about the Moon that will leave you starstruck. Let's get started. So how did the Moon come to be? Picture this. It's about 4.5 billion years ago, and the early solar system is a chaotic cosmic billiards game. Our young Earth is just minding its own business when, bam, a Mars-sized object named Theia slams into it. The impact is so cataclysmic that it sends a massive amount of debris hurtling into space. Instead of just flying off into the void, this debris, bound by gravity, slowly begins to clump together, like cosmic dust bunnies under your bed. Over millions of years, this debris coalesces, forming a sphere, cooling down and eventually becoming the familiar cratered orb we call the Moon. This is the giant impact hypothesis, the leading explanation for the Moon's existence. Pretty cool, huh? Now, let's talk size. The Moon might look pretty big in the night sky, especially during a full moon, right? But in cosmic terms, it's actually kind of puny. The Moon's diameter is about 3,474 kilometers, roughly the distance from New York City to Los Angeles. In fact, you could fit roughly 4 moons across the diameter of the Earth. On average, it's about 384,400 kilometers away from us. If we were to shrink the Earth down to the size of a basketball, the Moon would be about the size of a tennis ball, and they'd be about 24 feet apart. So the next time you look up at the Moon, remember it's not as big or as close as it appears, but that doesn't make it any less fascinating. We've all seen the footage of astronauts bouncing around on the Moon, looking like they've suddenly mastered the art of effortless movement. Well, that's lunar gravity at work. The Moon's gravity is much weaker than Earth's, about 1/6 to be precise. If you weigh 150 pounds on Earth, you'd feel like a featherweight at a mere 25 pounds on the Moon. The Moon is much less massive than the Earth, meaning it has a weaker gravitational pull. This weaker gravity is why astronauts could leap and bound across the lunar surface with such ease. It also means that if you were to kick a soccer ball on the Moon, it would travel much farther than it would on Earth. Just make sure you pack a spacesuit. Have you ever noticed how the Moon seems to change shape from night to night? Sometimes it's a full circle, other times it's a sliver, and sometimes it seems to disappear altogether. These different appearances are called lunar phases, and they're all caused by the Moon's orbit around the Earth and the changing angles at which we see the sunlit portion of its surface. It all starts with the new Moon, when the Moon is between the Earth and the Sun. As the Moon continues its orbit, a sliver of sunlight starts to illuminate its surface, creating a waxing crescent moon. This sliver grows larger each night, forming the first quarter moon, where half of the Moon appears illuminated. The illuminated portion continues to grow, creating a waxing gibbous moon until finally we reach the full moon, where the entire face of the Moon is bathed in sunlight. Now, let's dive into the incredible influence the Moon has on our planet, starting with the tides. The Moon's gravitational pull isn't uniform across the Earth. The side of the Earth facing the Moon feels a slightly stronger pull than the side facing away. This difference in gravitational force creates a bulge of water on the side of the Earth facing the Moon and another bulge on the opposite side. These bulges are what we experience as high tides. As the Earth rotates, different locations pass through these bulges, experiencing high tides approximately every 12 hours and 25 minutes. The Moon's gravitational interaction is also slowing down Earth's rotation over very long periods. This means that our days are getting slightly longer over time. Don't worry, though, it's only by a fraction of a second each century. Imagine yourself as an astronaut, suited up and ready to step out onto the lunar surface. The anticipation builds as you prepare to take that historic step. What awaits you is a truly alien landscape, unlike anything you've ever seen on Earth. The vast, desolate expanse stretches out before you, silent and still. The first thing you'd notice is the fine, powdery dust covering everything. This dust clings to your boots and suit, a reminder of the Moon's unique environment. This dust, called regolith, is made up of tiny fragments of rock created by billions of years of meteorite impacts. Each particle tells a story of the moon's violent past. As you look around, you'll see a stark, grey world dotted with craters of all shapes and sizes. These craters are like scars marking the moon's surface. These craters are the result of countless impacts from asteroids, comets and meteoroids over billions of years. Each impact has left its mark, creating a rugged terrain. You'll also notice large, dark, flat plains called maria, which were once ancient lava flows that erupted from the moon's interior billions of years ago. These plains add to the moon's mysterious allure. And then there are the highlands, the brighter areas of the lunar surface thought to be the moon's original crust, dating back to the very early solar system. These highlands stand as a testament to the moon's ancient origins. Here on Earth we take our atmosphere for granted. It provides us with the air we breathe, protects us from harmful radiation, and even helps regulate our climate, ensuring a stable environment for life to thrive. But on the moon, it's a very different story. The moon has a very thin atmosphere called an exosphere. It's so thin, in fact, that it's almost a vacuum. The air pressure on the moon's surface is about 10 trillion times weaker than the air pressure at sea level on Earth. This lack of a substantial atmosphere has some major implications. For starters, it means there's no air to breathe on the moon. Astronauts need to wear spacesuits that provide them with oxygen and protect them from the extreme temperatures and lack of pressure. It also means that the moon's surface is completely exposed to the harsh radiation of space. Without an atmosphere to shield it, the sun's ultraviolet radiation bombards the lunar surface, making it a very hostile environment for life as we know it. This lack of protection also means that any potential lunar habitats would need significant shielding to be safe for human habitation. Have you ever wondered why we only ever see one side of the moon from Earth? It's not just a cosmic coincidence, it's due to a phenomenon called synchronous rotation. The moon takes about 27.3 days to orbit the Earth. Interestingly, it also takes the moon about 27.3 days to rotate once on its axis. This means that the moon spins at just the right speed to keep the same face pointed towards us at all times. Think of it like this. Imagine you're walking around a tree, always keeping your face towards the trunk. You're still rotating, but you're always showing the same side to the tree. That's essentially what the moon is doing with the Earth. On July 20th, 1969, the world watched in awe as humans achieved what was once considered an impossible dream landing on the moon. This monumental event was broadcasted live, capturing the imaginations of millions around the globe. The Apollo 11 mission, crewed by Neil Armstrong, Buzz Aldrin and Michael Collins, marked a pivotal moment in human history. These brave astronauts embarked on a journey that would forever change our understanding of space and our place in the universe. As Neil Armstrong took those historic first steps on the lunar surface, uttering the now iconic words, "That's one small step for man, one giant leap for mankind," it signaled a new era of exploration. This moment was a testament to human courage, determination, and ingenuity. The Apollo missions weren't just about planting a flag on the moon, however. They represented a significant leap in our quest to explore the unknown and push the boundaries of what was possible. They were about pushing the boundaries of human ingenuity, expanding our scientific understanding of the moon and the solar system, and inspiring generations to come. The experiments conducted provided invaluable data that continues to influence space research today. The astronauts conducted experiments, collected lunar samples, and captured breathtaking images that gave us a whole new perspective on our celestial companion. These samples and images have been studied extensively, offering insights into the moon's composition and history. While the Apollo missions ended in 1972, our fascination with the moon hasn't waned. The legacy of these missions continues to inspire and drive our curiosity about the cosmos. With advancements in technology and a renewed interest in lunar exploration, we're on the cusp of a new era of lunar exploration. Future missions promise to uncover even more secrets of the moon and pave the way for human settlement on other celestial bodies. We've already talked about how the moon's gravity drives our ocean tides, but its influence on Earth goes far beyond that. One of the most significant ways the moon affects our planet is by stabilizing Earth's axial tilt. Earth's axis is tilted at about 23.5 degrees, and this tilt is what gives us our seasons. Without the moon's gravitational influence, Earth's axial tilt would be much less stable, wobbling chaotically over long periods. This wobble would lead to extreme climate shifts, making it much more difficult for life to evolve and thrive. So the next time you look up at the moon, remember that it's not just a pretty face in the night sky, it's a vital part of what makes Earth such a hospitable place for life. Thanks for watching. If you enjoyed learning about the moon, don't forget to like, subscribe, and hit the bell icon for more fascinating space facts. See you next time.